Hello guys, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video, we'll be looking into this beautiful topic, Laplace transform. So our aim in today's video is to find the Laplace transform of this following function: t raised to the power of n, e raised to the power of at, sine at, and cos at. So that is our aim for today. So before I start solving this problem, please don't forget to subscribe to my channel, like my videos, comment, share, and click the notifications button so that anytime I upload video, you'll be the first to watch. All right, guys, so now let's start. Before we solve this, let me quickly introduce the Laplace transform. Okay, so the Laplace transform is of a function f of t. So where t is greater than or equal to 0, okay, and is defined as, so we can use f of s to represent the Laplace transform of f of t. So f of s is equal to the Laplace transform of f of t, and then we have the integral representation of that, which is equal to integral from 0 to infinity e raised to the power minus st, then multiplied by f of t, the t. So here s is a member of the set of complex number, okay, and then the real part of s is sufficiently large, so for this integral to converge. So it's sufficiently large for the integral to converge. All right, guys, now that is that about the definition of the Laplace transform, and I will also like to explain something. The Laplace transform is a linear operation. Now, it's a linear operation in what sense? So let's say you are given a function, a f of t plus or minus b g of t, and you're asked to find the Laplace transform. So the Laplace transform of a f of t plus g f of t will be equal to a multiplied by the Laplace transform of f of t, then plus or minus b multiplied by the Laplace transform of g of t. So the Laplace transform is a linear operation. Okay, guys, so now that is that about that. So since we already know the definition of the Laplace transform, so we can now find the Laplace transform of the given function. So the first function we want to find the Laplace transform is t raised to the power of n. So we are asked to find the Laplace transform of t raised to the power of n. So I can say the Laplace transform of t raised to the power of n is equal to f of s. Okay, now in this case, f of t will be t raised to the power of n, and then from the integral representation of the Laplace transform, so we have f of s equals integral from 0 to infinity e raised to the power of minus st, then f of t, the t. Okay, we know that, so f of t will be t raised to the power of n. So f of s will be equal to integral from 0 to infinity e raised to the power of minus st, then multiply by f of t, which is t raised to the power of n, the t. Okay, so now let's move on. So let's try and solve this integral. So now solving this integral, we can make a substitution. We can let st be equal to x. So if we do that, so t will be equal to x over s. Then we have the t equals the x over s. But take note, the limit is not changing, because if you put infinity, you have infinity, put 0, you got 0. Okay, so we have f of s is equal to integral from 0 to infinity e raised to the power of minus x, then multiply by t, which is x over s, then raised to the power of n, and the t, which is the x over s. So we can bring out 1 over s. So we are going to have f of s is equal to 1 over s multiplied by integral from 0 to infinity e raised to the power of minus x multiplied by x raised to the power of n over s raised to the power of n dx. So we bring out 1 over s raised to the power of n. So we have f of s is equal to 1 over s raised to the power of n plus 1 multiplied by integral from 0 to infinity e raised to the power of minus x raised to the power of n dx. Now we know that the gamma function of n plus 1 is equal to integral from 0 to infinity e raised to the power of minus x multiplied by x raised to the power of n plus 1 minus 1. Okay, so that is the gamma function definition. So we can now say that f of s is equal to 1 over s raised to the power of n plus 1, then multiplied by gamma of n plus 1. Because if you write this integral, you can write it as integral from 0 to infinity e raised to the power of minus x, x raised to the power of n plus 1, then minus 1 dx. So we have n plus 1. So now let's move on. Moving on, we have f of s is equal to 1 over s raised to the power of n plus 1, then multiplied by gamma of n plus 1. That is where we have. Then remember that gamma of n plus 1 is equal to n multiplied by gamma of n. And also, gamma of n is equal to n minus 1 factorial. So gamma of n plus 1 will be equal to n multiplied by n minus 1 factorial. And then remember that n factorial is equal to n multiplied by n minus 1 factorial. So we can say that gamma of n plus 1 is equal to n factorial. Okay, then we have f of s is equal to 1 over s raised to the power of n plus 1 multiplied by n factorial. Therefore, the Laplace transform of t raised to the power of n is equal to n factorial over s raised to the power of n plus 1. Now let's do some example. Let's say you are asked to find the Laplace transform of t raised to the power of 0, or let's just say you are asked to find the Laplace transform of 1. Now, in this case, the value of n will be 0 because t raised to the power of 0 will give us 1. So we are going to have 0 factorial over s raised to the power of 0 plus 1. And 0 factorial will give us 1, so we have 1 over s. That's the Laplace transform of 1. Let's say you have to find the Laplace transform of t. So in this case, n will be equal to 1. So we have 1 factorial over s raised to the power of 1 plus 1 is equal to 1 over s raised to the power of 2. And that is how you find the Laplace transform of a such function. Okay, now let's move to the next part. The Laplace transform of e raised to the power of 80. So how to find the Laplace transform of e raised to the power of 80? Okay, so we can say this is equal to f of s. Then if we do that, we are going to have f of s is equal to integral from 0 to infinity e raised to the power of minus st. Then our f of t is e raised to the power of 80 the t. So we have f of s equals integral from 0 to infinity. If you apply the law of indices, so that will be e raised to the power of minus st plus 80 the t. So you can factor out t in the exponent. So we are going to have f of s equals integral from 0 to infinity e raised to the power of t into bracket minus s plus a the t. So now making substitution, we can put t into bracket minus s plus a to be equal to x, then t will be equal to x over minus s plus a, which can also be written as t equals x over a minus s. Then we have the t equals the x over a minus s. Then we have f of s equals integral from 0 to infinity e raised to the power of x, since t into bracket minus s plus a is x. Then the t is the x over a minus s. Now, bringing out 1 over a minus s, we're going to have 1 over a minus s multiplied by integral from 0 to infinity e raised to the power of x dx. So if we integrate e raised to the power of x, it's still e raised to the power of x. So we have f of s equals 1 over a minus s, then into bracket e raised to the power of x, then it's from 0 to infinity. So this will be equal to 1 over a minus s, then into bracket e raised to the power of infinity minus e raised to the power of 0. So we have 1 over a minus s, then into bracket 0 minus 1. And 0 minus 1 will give us minus 1. So we have minus 1 over a minus s, which is also equal to 1 over s minus a. Therefore, the Laplace transform of e raised to the power of 80 equals 1 over s minus a. Alright, what if we are asked to find the Laplace transform of a function in this form. Let's say you are asked to find the Laplace transform of, e raised to the power of t. So we want to find the Laplace transform of e raised to the power of t. So in this case, the value of a is just 1. Okay, the value of a is 1. So Laplace transform of e raised to the power of t, so that will be 1 over s minus 1. So that's the Laplace transform of e raised to the power of t. So what you have to find Laplace transform of e raised to the power of 2t. So the value of a here is 2. So you're going to have 1 over s minus 2. So that is that about that. That's how you find the Laplace transform of a such function. Okay guys, now let's move to the next function that we have to find. So which is sine 80. We are done with this. We're done with this. The next one is sine 80. So the Laplace transform of sine 80. All right. So we want to find Laplace transform of sine 80. So I'm going to use two methods in finding the Laplace transform of sine 80. Okay. So the first method I will be using is using the integral the integral method. So now using the integral method, so f of t will be sine 80. So we're going to have f of s equals integral from 0 to infinity, then e raised to the power of minus st, then multiplied by sine 80 the t. Now from Euler's formula, remember that sine 80 is equal to the imaginary part of e raised to the power of I80. Okay, so sine 80 is equal to imaginary part of e raised to the power of sine e raised to the power of I80. Okay, so we're going to have f of s is equal to the imaginary part of integral from 0 to infinity, e raised to the power of minus st, then multiplied by e raised to the power of I80, the t. Okay, now moving on. So applying the law of indices here, we're gonna have imaginary part of integral from 0 to infinity, e raised to the power of minus st plus I a t the t. So now we can factor out t. So if we do that, we're gonna have imaginary part of integral from 0 to infinity, then e raised to the power of t, then into bracket minus s plus I a the t. So now making a substitution, so we can also bring out negative sign. Yes, if we bring out negative sign, we're going to have imaginary part of integral from 0 to infinity, e raised to the power of minus t, then into bracket s minus ia, then dt. So now let's make a substitution. Put t then into bracket s minus ia to be equal to x. Then we have t equals x over s minus ia. Then we have the t equals the x then over s minus ia. Okay. So we're gonna have imaginary parts of then the integral from 0 to infinity, then e raised to the power of minus x. So since t into bracket s minus ia is x, then dt is the x then over s minus ia. So we can bring out 1 over s minus ia, so we have imaginary parts of 1 over s minus ia, then integral from 0 to infinity, e raised to the power of minus x dx. So that will be imaginary parts of 1 over s minus ia. Then if you integrate e raised to the power of minus x, so that is minus e raised to the power of minus x. Then you take the limit from 0 to infinity, from 0 to infinity. So we have the imaginary parts of 1 over s minus ia, then into bracket, then minus e raised to the power of minus 0, then minus minus that will be plus e raised to the power of 0. Minus infinity here. So we have imaginary parts of 1 over s minus ia, then into bracket, so this should be 0, then a 1. Alright, so what we have now is imaginary parts of 1 over s minus ia. So let me clean these parts so that we can have some space to solve the remaining problem. Okay guys, so let's move on. So let's find the imaginary parts of 1 over s minus ia. Okay, so what I'm going to do now is to rationalize. So if I rationalize, I'm going to multiply both the numerator and the denominator by the conjugate of this denominator. So I'm going to have s plus ia then over s minus ia multiplied by s plus ia. So this will be equal to s plus ia then over, then if you open the bracket here, s multiplied by s will give us s squared, then plus s multiplied by ia will give us ias, then minus ia multiplied by s will give us minus ias, then minus ia multiplied by ia, that should give us plus, yeah, that should give us plus a squared, because I multiplied by I will give us negative 1, a multiplied by a will give us a squared, then multiplied by this negative, so that should give us plus a squared. So this will be equal to s plus ia then over, so ias we cancel out ias over s squared plus a squared. So but don't forget, we can write this as s over s squared plus a squared and plus a over s squared plus a squared high. So we need imaginary parts. So the imaginary part of s over s raised to the power of 2 plus a squared, then plus a over s raised to the power of 2 plus a squared I. So this is equal to a over s squared plus a squared. So that's the Laplace transform of sine 80. So the Laplace transform of sine 80 is a over s squared plus a squared. Okay guys, now let's move on. Using the second method, if you don't want to use that method, now let's make use of second method. Okay, so let me clean this part. Now, second method. So if we want to use the second method, we can make use of the Euler method. Are we together? So make use of Euler method. So Laplace of sine 80. Now remember that sine 80 is equal to 1 over 2i multiplied by e raised to the power of minus I 80, then minus 1 over 2i multiplied by e raised to the power of I 80. Okay, then if you now take the Laplace transform, that is Laplace transform of 1 over 2i e raised to the power of minus I 80, then minus 1 over 2i e raised to the power of I 80. All right, now remember that from the theorem I gave earlier, I said Laplace transform is a linear operation. So we apply linearity, so we're going to have 1 over 2i, then multiply by the Laplace transform of e raised to the power of minus I80, then minus 1 over 2i multiplied by the Laplace transform of e raised to the power of I80. And then remember that Laplace transform of e raised to the power of 80 is equal to 1 over s minus a. So now Laplace transform of e raised to the power of minus I80, in this case, a will be equal to minus IA. That will be the value of a here. Okay, so we input a to be minus IA here, so we're going to have the Laplace transform of minus I80 equals 1 over s then minus IA. So this will give us 1 over s plus IA. That's Laplace transform of e raised to the power of minus I80. Then what will be the Laplace transform of e raised to the power of I80? So here a will be equal to IA. So this will be equal to 1 over s minus IA. So guys, we have the Laplace transform of this and we have the Laplace transform of this. So this work should be easy for us to solve. So let me clean this part so that we can be able to find the answer to the problem. Okay guys, now moving on. So we are going to have 1 over 2 I, then multiply by the Laplace transform of e raised to the power of minus I80, which is 1 over s plus IA, 1 over s plus IA, then minus 1 over 2i, then Laplace transform of e raised to the power of I80, which is 1 over s minus IA. So we can see that 1 over 2i is common here, so we can factor out 1 over 2i. So if we factor out 1 over 2i, we are going to have 1 over 2i, then into bracket 1 over s plus ia, then minus 1 over s minus ia. So this will be 1 over 2i, so the LCM here will be s plus ia, then multiply by s minus ia. So this will be s minus ia, then minus s plus ia. So now let's clean the other parts so that we can have enough space to solve. All right, guys, let's move on. So we are going to have 1 over 2i, then into brackets. Now, so this will be s minus ia, then minus times s, that will be minus s, then minus times plus ia, that will be minus ia, then over, then s plus ia, then multiply by s minus ia. So we can see s minus s, that should give us 0, then minus ia minus ia, so that should give us minus 2ia. So we have 1 over 2i, then into brackets minus 2ia, then over. Now take note, difference of 2 square, a plus b multiplied by a minus b. So this is equal to a squared minus b squared. So s plus ia multiplied by s minus ia. So this will be s squared minus, then b should be ia squared. So this will be s squared minus a squared, and this is s squared plus a squared. So this denominator is s squared plus a squared. Okay, so let me just clean this. It's just for explanation how to get that s squared plus a squared. Okay, now let's move on, guys. Okay, so we can see that 2 is going to cancel out 2. So what we have now is I, then multiply by minus ia, then over s squared plus a squared. So I multiply by minus I, that should give us 1, because I multiply by I is negative 1, then multiply by this negative 1, so we have 1, then multiply by a, so we have a over s squared plus a squared. So that is how you find the Laplace transform of sine 80 using the Euler's method without the making use of the integral method. Okay, guys, so that is that about Laplace transform of sine 80. Now let's do some example. Let's say you have to find the Laplace transform of 2 sine 80. So of 2 sine, let's say 3t, all right? So this will be equal to 2, then multiply by Laplace transform of sine 3t. So in this case, the value of a will be 3. So we are going to have 2, then multiply by 3, then over s squared plus 3 squared. And don't forget 3 squared will give us 9, and 2 multiplied by 3 will give us 6. So you have 6 over s squared plus 9. So that's how you find the Laplace transform of a function in form of sine 80. All right, guys, now let's move on to the next part, finding the Laplace transform of cos 80. So Laplace transform of cos 80, so we can also say this is equal to f of s. Now, using the integral method, so f of s will be equal to integral from 0 to infinity of e raised to power minus st, then cos 80 t. Remember from the Euler's formula, cos 80 is equal to the real part of e raised to the power of I80. Okay, so that's cos 80. Then we're going to have f of s is equal to the real part then of integral from 0 to infinity e raised to the power of minus st, then multiply by e raised to the power of I80, then the t. Okay, so this should be real parts then of integral from 0 to infinity of e raised to the power of minus st plus I80 t. So we factor out t, so we're going to have the real part of integral from 0 to infinity e raised to the power of t into bracket minus s plus ia the t. So then if you make a substitution, so you can say let t into bracket minus s plus ia be equal x. Then we have t equal x over minus s plus ia. So which is also t equal x over ia minus x. Then we have the t equal the x over ia and minus s. Okay, so let's clean this part. All right, so guys, let's move on. So this is the t, then that is the t that we are going to have real part then of integral from 0 to infinity, then e raised to the power of x, then the t is the x over IA minus s. Okay, so this will be equal to, so bringing out 1 over IA minus s, so we have the real parts of 1 over IA, then minus s, then multiply by integral from 0 to infinity e raised to the power of x. So if you find the integral of e raised to the power of x from 0 to infinity, that should give us -1. So what we have now is the real part of 1 over IA minus s, then multiply by -1. And so that will be real parts of 1 over s minus IA. So that's what we're going to have. So our new task is to know the real part of 1 over s minus IA. Okay, so that was beautiful. So let's clean this part. So cleaning this part, you can also try and find the real part of 1 over s minus IA. It's like the way I find the imaginary part of 1 over s minus IA in when we were solving for the Laplace transform of sine 80. Okay, so now let's start. You rationalize. So we rationalize 1 over s minus IA, that will be s plus IA, then over s minus IA multiplied by s plus IA. So this will be equal to s plus IA, then over s squared plus a squared. So we have s squared plus a squared. Okay, so then if you split that, so that will be equal to s over s squared plus a squared, then plus a over s squared plus a squared multiplied by I. So taking the real parts of s over s squared plus a squared, then plus a over s squared plus a squared I. So the real part is s over s squared plus a squared. Therefore, the Laplace transform of cos AT is equal to s over s squared plus a squared. So that's how you find the Laplace transform of cos AT, making use of the integral method. But you want to use the Euler method. Now, we know that cos AT, all right? So we know that cos AT is equal to 1 over 2 e raised to the power of minus IAT, then plus 1 over 2 e raised to the power of IAT. Now, so taking the Laplace, we're going to have Laplace transform of 1 over 2 e raised to the power of minus IAT, then plus 1 over 2 e raised to the power of IAT. So this will be equal to 1 over 2 Laplace transform of e raised to the power of minus IAT, then plus 1 over 2 multiplied by the Laplace transform of e raised to the power of IAT. Okay, and then we already know that Laplace transform of e raised to the power of AT is equal to 1 over s minus a. So to find the Laplace transform of e raised to the power of minus IAT, so here a is equal to minus IA. So Laplace transform of e raised to the power of minus IAT, so this will be equal to 1 over s plus IA. Then that is how you find for this also. So Laplace transform of e raised to the power of IAT, so that one will give us 1 over s minus IA. I already explained this earlier. All right. So now let's move on. So moving on, let me clean some parts here. Okay, guys, so we're gonna have the Laplace transform of this and this. We already have that, so that will be 1 over 2. Then the Laplace transform of e raised to the power of minus IAT, that is 1 over s minus IA. Sorry, that is 1 over s plus IA, 1 over s plus IA, then plus 1 over 2, then Laplace transform of e raised to the power of IAT, that is 1 over s minus IA. So we can now clean this part. Okay, so we are getting there. It's not hard anymore. All right, so let's move on. So we can factor out 1 over 2. So we factor out 1 over 2, that will be 1 over 2, then into bracket 1 over s plus IA, then plus 1 over s minus IA. So this will be 1 over 2, then the LCM here will be s plus IA, then multiply by s minus IA. So we're going to have s minus IA, then plus s plus IA. So this will be 1 over 2, then into bracket. So minus IA plus IA is 0. Then s plus s will give us 2s. And then if you multiply this, so we are going to have s squared plus a squared, and 2 we cancel out 2. So what we have is s over s squared plus a squared. Therefore, the Laplace transform of cos at is equal to s over s squared plus a squared. So that's how you do that. So let's say you are asked to find the Laplace transform of 5 cos 2t. So this will be equal to 5 multiplied by Laplace transform of cos 2t. And then we already know how to find the Laplace transform of this kind of function. So that shows that the value of a is 2. So we're going to have 5 multiplied by s, then over s squared, then plus 2 squared. So this will be 5s then over s squared plus 4. So that is that about that. All right, guys. So that is how you find the Laplace transform of such a function. So that will be the end of our lecture for today. So if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and share. Thanks, guys, for watching. See you next.